Let's go ahead and practice working with one-step equations together. So in this first set of problems 1 through 4, let's go ahead and see if we can solve these equations, but we're going to use these justifications provided. So for the first one, for number 1, looks like we're just going to copy down the equation. We have x plus 9/10. Let's go ahead and write the left side. That expression is equal to the right side. The expression on the right is just negative 1/4. Okay, so there's only one value for x that would make this equation true, but we're going to go ahead and use the subtraction property of equality. So if we're going to use the subtraction property of equality, we got to ask ourselves, what would we subtract both sides of this equation by so we can get x alone? Now, I think we're going to go ahead and subtract 9/10 just because we can get 0 on the left side, which would be really nice because then we don't have to write it. So if we go ahead and take away 9/10 from both sides of the equation, we're using the subtraction property of equality. Okay, once we go ahead and do that, we're going to go ahead and rewrite the fractions using the least common denominator. So on the left side, we don't really have to do anything because they have common denominators. But on the right side, think about the LCD of 4 and 10. I think they meet at 20 for the first time. So just go ahead and copy this left side, x plus 9/10 minus the 9/10 over here. And then on the right side, if you rewrite the fractions using a denominator of 20, we'll do times 5 times 5, so it's negative 5 over 20. And then I'm going to go ahead and write plus a negative just because it's a little easier for me to wrap my head around. And then I'll do times 2 times 2, so it's going to be 18 over 20. Okay, so we have common denominators there. Let's go ahead and simplify this thing a little bit using the additive inverse property. Again, this 9/10 minus 9/10 is the same thing as 9/10 plus negative 9/10, which is 0. So that's using the additive inverse property. So we have x plus 0 on the left side. And on the right side of the equation here, a negative plus a negative is just more negative. So this would be negative 23 over 20. Up to you if you want to write a mixed number, but this is fine. And then simplifying using the identity property of addition, we can drop that 0 and just say x is equal to, and if you want to write it as an improper, that's fine. We can write it as a mixed and say negative 1 and 3/20. Either way is fine, but this would be our solution. And of course, if you wanted to go ahead and check to see if the solution is correct, you would take this and substitute it in for x over here and add 9/10, and you would see if it equals this negative 1/4 after you simplify. Okay. Let's check out number 2. For number 2, we have this equation negative 9 and 5/9 is equal to y minus this 2 and 1/6. So first we're just going to copy down the original equation. So negative 9 and 5/9 is equal to y minus this 2 and 1/6. All right, cool. So let's see, we're going to go ahead and use the addition property of equality. So what are we going to add to both sides? Well, we're trying to get this y alone. So what are we going to add? Well, if we add 2 and 1/6, then this minus 2 and 1/6 is going to go away, right? So let's go ahead and write negative 9 and 5/9 on the left side. Let's go ahead and add 2 and 1/6 on the left side of the equation. Now, if you do it on the left side, you have to do it on the right side as well. So copy down the expression on the right side, but then go ahead and add the 2 and 1/6 just so we're balanced on both sides of the equation, right? Now we're going to go ahead and rewrite these fractions using the least common denominator. So on the right side, we're just going to keep that the same, but on the left side, ask yourself, when do 9 and 6 meet for the first time? So I think the LCM of 9 and 6 is 18. So let's see, it's going to be negative 9 times 2 times 2 is going to be 10 over 18 plus 2, and then times 3 is going to be 3 over 18. And then on the right side, we're just going to copy y minus 2 and 1/6 plus 2 and 1/6 for now. Okay. Let's go ahead and use the additive inverse property, and that's what is over here. If you add these opposites here, you're going to get 0. So we're going to get on the right side just y plus 0. And on the left side of the equation, if you go ahead and add these two fractions, let's see, you can just subtract the larger absolute value from the minus the smaller absolute value from the larger absolute value. And this one works out pretty nicely. So 9 minus 2 is going to be 7, and 10 minus 3 is also going to be 7. So I think this is going to be negative 7 and 7/18 here. All right, so it's kind of nice we didn't have to do any borrowing or anything. And then using the identity property of addition, that just says anything plus 0 stays the same. So we can just say negative 7 and 7/18 is equal to y. And you could turn this around too if you wanted to put y on the left side, but I'm just going to leave it like this for now, but totally up to you if you want to keep the variable on the left side. All right, let's check out number 3. For number 3, we have this equation, but this time we don't have any adding or subtracting. We just have multiplying. So we have negative 6 and 2/3 is equal to 2/5 multiplied by some unknown value, which we're calling n. So let's go ahead and just write down the original equation. So it's going to be negative 6 and 2/3, and say that's equal to 2/5 of something, or 2/5 times this value. So we're being asked to use the multiplication property of equality. I totally think that you can use the division property of equality too if you want to divide both sides by 2/5. But it's a little bit quicker, or I think more efficient, to multiply both sides by a reciprocal here. So let's go ahead and take this, and I'm actually going to rewrite this as an improper fraction just because when we're going to have to multiply in just a moment. So I'm going to write this as negative 20/3. Right? And then we're going to multiply by what? We're going to multiply by 5/2 because that's the reciprocal of the coefficient. So I'm going to multiply by 5/2. And on the right side, we have this 2/5 times n. But I'm also going to multiply this by 5/2. All right. So again, you could divide both sides by 2/5, but you'll quickly hopefully realize that if you divide both sides by 2/5, it's the same thing as multiplying by both sides by 5/2. Okay. Now let's go ahead and says use the multiplicative inverse property. So that's just on the right side here. Keep in mind, if you multiply reciprocals, which are these two values here, you'll get 1. So using the commutative property, you can just rearrange those and multiply them first. So that's going to be 1n. And on the left side of the equation here, you can get a cross cancel. This will become a 1, this will become a 10. So then let's see, 5 times 10 is 50. So we're looking at 50/3, I believe. So it's negative 50/3, just because we have a negative multiplied by a positive. Now, if you want to go ahead and drop the 1 using the identity property of multiplication, 1n is just n. And on the left side, you can leave it as an improper or as a mixed. I believe this is going to be 16 times 3 is 48 with 2 left over. So you can say negative 16 2/3 is equal to n. And again, you can always turn this around using the reflexive property as well if you felt like writing the n first. Okay. If you wanted to check this, of course, you could take the 2/5 here, multiply it by this negative 16 2/3, and just verify that it does equal negative 6 2/3 just to practice and make sure your answer or solution is valid. All right, here's one more example of these types. Let's write down the original equation here. We have 3/8 is equal to 6/7 of some number here, some number n. So that's the original. Now let's go ahead and use the multiplication property of equality. This is very similar to the last example, just a little bit more practice. So we really want the coefficient of this n to be 1, but right now it's 6/7. So how do we make it 1? Well, if we go ahead and multiply both sides by its multiplicative inverse of 7/6, then we'll be able to get that 1. So on the left side, take the 3/8 and multiply by 7/6. And on the right side, let's go ahead and also multiply this side by 7/6. Okay, so on the right side here, this is very similar to the last example, so hopefully this is making more sense. These two are multiplicative inverses, so if you multiply them together, you get 1, so we're looking at 1n. And on the left side of the equation, let's go ahead and see, you can multiply the tops and the bottoms, but I think we can cross cancel the 3 and 6 using their GCF. If we divide them both by 3, we'll get 1 and 2. And then so 1 times 7 is 7, and 8 times 2 is 16, so we're going to have 7/16. And it looks like we don't have to deal with any negatives or anything here. Using the identity property of multiplication, we can go ahead and drop this 1 here and just say 7/16 is the value of n, or n is equal to 7/16. Again, if you wanted to check this, take that 7/16, plug it in right here, multiply it by 6/7 and simplify. You should get 3/8 if you did it correctly. All right, let's try some different set of problems here. So for questions 5 through 10, we're going to go ahead and solve each of these equations, but we're going to go ahead and make sure that we do use a property of equality, at least one inverse property, an identity property, and then we'll go ahead and check to see if our solution makes sense by substituting. We're going to show all the calculations we did. So if we can do stuff in our head, great, but if we need to write something out, it needs to be written out. All right, so for number 5 here, the property of equality I'm going to use is the addition property of equality. Let's go ahead and add 8 to both sides. That's the addition property of equality. Then once you go ahead and do that, we're going to have negative 8 plus 8, that using the additive inverse property, that's just going to be 0, right? So you don't have to write the properties down, but hopefully as we talk it out loud, it makes sense where we are using it. And on the right side, negative 13 plus 8 is going to be negative 5. Now using the identity property of addition, we can drop that 0 and just say x is equal to, and that's going to be negative 5. So this would be our solution, but it does say to go ahead and show that we checked our solution as well, right? So substituting in our answer of what we think is true, let's say negative 5 minus 8. Let's see if that is potentially equal to this negative 13. Right, so if we go ahead and do negative 5 minus 8, that's negative 5 plus negative 8, that is negative 13. So if negative 13 does equal negative 13, that means we must have done a good job here. Okay, let's check out number 6. For number 6, let's look like we have addition as the operation. So to get y alone here, let's go ahead and subtract 3 2/3 from both sides of the equation. So if you're wondering, we are using the subtraction property of equality here. Okay, so we've got to make sure we subtract on both sides. If we do that, then we're going to be left with y plus 0 on the left side, just because these are additive inverses of each other. They get 0 if you add them together, right? And then on the right side, we have to go ahead and figure out what this is. So this is going to be negative 7 1/2. Take away 3 2/3, or add a negative 3 2/3, right? So looks like we're going to need common denominators here. So we can use 6 for that. So negative 7 3 6 plus negative 3 4 6. Okay, so adding two negatives is not too bad. This is going to be negative 10 7 6. Which simplifies to negative 11 1/6. So I think if we go ahead and subtract those two negative fractions together, we're going to get negative 11 1/6 here. Now, if we go ahead and use the identity property of addition, we can drop the 0 and just say y is equal to negative 11 1/6. I believe this should be our solution. But how do we verify this? Well, we can go ahead and substitute it into the original equation. Take this, substitute it here just to double check. So let's take this a negative 11 1/6. Let's go ahead and add the 3 2/3 and see if this is going to be equal to that negative 7 1/2. Okay, so let's see. On the left side, we need some common denominators. So let's use 6 here, I think, right? So negative 11 1/6 plus 3 4 6. Let's see if that's equal to the negative 7 1/2. Okay. So I think we're going to have to subtract this one from this one using their absolute values, but I think we're going to need to borrow a little bit. So let's make this one negative 10 7 6. And then so it's plus 3 4 6. Right? The reason we can do that is just regrouping the whole number in the fraction part so that we can actually subtract here. Right? So we can just go ahead and do 10 minus 3, which is 7, and then 7 minus 4, which is going to be 3. So it's going to be negative 7 3 6, but 3 6 is 1/2. So we do have negative 7 1/2 is equal to negative 7 1/2. So the checking here is actually quite a bit of work here, just a double check, but hopefully that was good practice to make sure that this does indeed work. All right, let's check out number 7. For number 7, we have some decimals here. I'm going to go ahead and rewrite this one just because with these fractions, it's oftentimes a little bit easier when we have more space, a little bit easier to keep organized. So just copying down this equation. Now, first thing we're going to do is think of a property of equality. So we do see that hopefully there's a 1/9 multiplied by this e. So what we're going to do is use let's go ahead and use the multiplication property of equality. So you can think about it as 1/9 times e, or e divided by 9. So instead of taking e and dividing by 9, if we go ahead and multiply both sides by 9, this is using the multiplication property of equality, right? So again, there is a 1 here that's invisible by the identity property of multiplication. So if you take this 1/9 and multiply it by 9 wholes, those are reciprocals or multiplicative inverses. So you're going to see that that is just going to be 1e on the left side of the equation. And on the right side, we need to go ahead and just multiply this 4.29 or 429 times 9. Put that decimal in a little bit. That's going to be 81. Carry the 8. That's going to be 18 plus 8 is going to be 26. Carry the 2. 36 plus 2 is going to be 38. I think we need 2 decimal places. So I think this is going to be a negative 38.61. So we can go ahead and use that multiplication identity property and say e is negative 38.61. Okay, so going from the top here, we went ahead and used the multiplication property of equality. Then if we go ahead and multiply the multiplicative inverses together, we do get this 1e. Then if we go ahead and use the identity property of multiplication, we can drop this 1 and just write e instead. Now if we want to go ahead and just check this, let's take this negative 38.61. Let's go ahead and divide that by 9. And this should hopefully be equal to this negative 4.29. Okay, so if we do that, we should be doing some long division here just to check. So let's go ahead and take this 38.61, divide that by 9. The decimal can go right up here. 9 goes into 38 4 times. That's going to be 36. If we subtract here, that's going to be 2. Bring down the 6 here. Let's see, 3. No, I'll go with 2 here. 2 times 9 is 18. 26 minus 18 is going to be, let's see, that's 2 plus 6 is 8. That's 8. Bring down the 1 here. 9 into 81 is 9 times. 9 times 9 is 81. We get a remainder of 0. So you do see here that it's a negative divided by a positive, so it's negative 4.29. We just verified is equal to negative 4.29. So this does check out, so we know our solution is correct. All right, let's go ahead and check out number 8. For number 8, we got some fractions again. We have, let's see, an expression is equal to a difference on the right side. So here's a difference. So if we see a difference, we should be using the addition property of equality to go ahead and balance that out. So let's go ahead and add 1 3/8 to both sides of this equation. Now, if we go ahead and add 1 3/8 to both sides, negative 1 3/8 plus a positive 1 3/8, those are additive inverses. So we're going to get k plus 0. And if you want to just go ahead and write this and use the identity property of addition and just get rid of that 0, then we could just focus on the left side here. So on the left side, we have to go ahead and take this negative 3 5/6. Let's go ahead and add 1 3/8. Let's go ahead and see, we need common denominator. So 6 and 8 meet at 24 for the first time. So negative 3, let's do times 4 times 4. So that's 20 over 24. Let's do times 3 times 3. So that's going to be 9 over 24. Okay, I think this one works out pretty nicely just because 3 is bigger than the 1, and also the 20 is bigger than the 9, so you can just subtract these. So 3 minus 1 is going to be 2. So we're looking at negative 2 and I believe 11/24. So I believe k is equal to negative 2 and 11/24. So we can go ahead and just copy that down a couple times here since we went ahead earlier on the right side. So I think right here this would be our solution. Okay, so let's go ahead and check this to make sure it does work though. Let's go ahead and take the negative 3 5/6, the left side of the equation. Let's see if that's equal to the right side, which we think k is what? Negative 2 and 11/24. And we gotta go ahead and subtract 1 3/8. We gotta see if this is true. So let's go ahead and figure out what this is over here. I'm gonna take this negative 2 and 11/24. If we take away 1 3/8, it's the same thing as adding a negative. And let's make them common denominator. So times 3 times 3 is going to be 9 over 24. And adding two negatives, negative 2 plus negative 1 is negative 3. Negative, we have 11, I guess, plus 9 is going to be 20. So it's going to be 20 over 24. And then you can use the GCF of 20 and 24, which is 4, and divide them both by 4. We'll have negative 3 and 5/6. Is that what we want? I think that's what we want, right? So that's good. So it's going to be negative 3 and 5/6 is equal to this negative 3 and 5/6. So this does work out. So our solution of this negative 2 and 11/24 must be correct. All right, let's check out number 9. All right, so we have this equation. We have subtraction as our operation. So let's go ahead and use the addition property of equality. Let's add 8.42 to the right side and add 8.42 to the left side. All right, so if we go ahead and do that, on the right side, we're going to have this h plus, and then these are additive inverses, so they're going to add to make 0. And then we can use the identity property of addition and drop that 0 and just say we have h. On the left side of the equation, we have to figure out what this is. We can go ahead and do that by just taking the number that has the greater absolute value and subtracting the number with the smaller absolute value, and then think about the signs afterwards. So let's see, 8.42 minus 4.595. Let's go ahead and borrow. That's going to be 7. This will be 14, but then it becomes a 13. This becomes a 12. 12 minus 5 is 7. 13 minus 9 is 4. 7 minus 4 is going to be 3. So I believe we're looking at positive 3.47 just because the 8.42 had a greater absolute value. And so I think this right here would be our solution, but let's go ahead and check it just to make sure. So let's see, negative 4.95. Let's see if that's equal to this. We think it's what, 3.47. Let's go ahead and substitute in positive 3.47 and take away this 8.42. All right, so if we're going to go ahead and do 3.47 minus 8.42, we can just go ahead and take 8.42 and take away 3.47. And then make it negative afterwards, right? So make this a 7, this becomes a 14, but then becomes a 13. This becomes a 12. 12 minus 7 is going to be 5. 13 minus 4 is going to be 9. 7 minus 3 is going to be 4. So we have 4.95. So that's good, right? Negative 4.95 is equal to this negative 4.95. Put that negative back in, okay? So this does check out, and h does equal 3.47. All right, here is one more practice problem for number 10. We have some fractions here. We have 2/3 c is equal to 10/9. So again, all these ones with fractions where we're multiplying or dividing, I think it's gonna be a little bit easier to rewrite them. So we have the space to show our calculations and our work. This is 2/3 multiplied by c. So you could totally divide both sides by 2/3 just to get 1 for the coefficient. But keep in mind, you can also use the multiplicative inverse right away. So we can use the multiplication property of equality, while we're also using the multiplicative inverse property in general, right? So these are multiplicative inverses of each other. So if you multiply those, you're gonna get 1c, which is really just going to simplify down to being c, right? Now on the right side of the equation here, you can go ahead and do it on the side, or you could just cross cancel here. These you can divide both by 2, so that's a 1 and a 5. These you can divide both by 3, so that's going to be 1 and 3. So that's using their GCFs to simplify. So 5 times 1 is 5, 3 times 1 is 3. So we're looking at 5/3 for our solution. And so I'm just going to write it as an improper fraction, but feel free to write it as a mixed number if you want to. If it's not a word problem or application, it's totally okay, I think, to write it as an improper fraction. So let's go ahead and check this. Let's take this 2/3. Let's go ahead and multiply. We think the answer is 5/3. Let's just verify this real quick. Let's see if this is equal to the 10/9 that we have on the right side of the equation. So 5 times 2 is 10, 3 times 3 is 9. There wasn't any cross canceling, so this does look like it was a pretty quick check, and that our answer is indeed 5/3 for C. All right, cool. So that wraps up this video on 10 different practice problems on understanding how to solve one-step equations. Hopefully you're getting a lot more fluent with understanding all the different properties and all the types of rules that we can kind of implement together to make sure we have a full understanding of why we're doing what we're doing and how we're doing what we're doing. So if you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.